we're going to use the combustion of gasoline as an example to talk about exergonic chemical reactions. So exergonic reactions are reactions in which energy is released over the course of a chemical reaction. And so the products were going to have less energy than the reactants. So in the example of gasoline, we have our reactants, like in all chemical reactions, starting on the left side. And so here our reactants are octane, which is C8H18. That's one of the major components of gasoline. And then oxygen, like we have in all combustion reactions. Okay, and so the octane molecules and oxygen molecules collide with each other, but unless they have enough energy, then the bonds in those molecules aren't going to break. They're just going to bounce off of each other. In order for a reaction to occur, we have to get the energy of the reactants up to there. So that's our activation energy. That's how much energy we need for the reaction to occur. So once we reach that amount of energy, the bonds in the octane and oxygen molecules are broken, and the atoms that are separated now reform, like come back together to make water molecules and carbon dioxide molecules. Those are the products of our reaction. And so once we get these products, we have less energy in our products than we did in the reactant. So the question is, where did that energy go? To look at this more closely, we're going to look at an example of a car, because we burn gasoline in cars. So in the car engine, you put the octane into the engine, like it's sent from the fuel tank into the engine. It reacts with oxygen in the air, and that reaction starts when you turn the key and the spark plug lights a spark. So that spark adds enough energy to hit the activation energy. Once the activation energy is achieved, then the reaction starts taking place and energy from the reactants is released into the environment. So how is that energy released? First way it's released is as sound. So cars aren't quiet unless they're they aren't silent unless they're electric, and then they still make a little bit of a sound. But cars make noise. So a lot of the energy that is being produced from this reaction is going into noise that the car sends off into its surroundings. Second thing that cars produce a lot of is heat. The engine gets hot because there are millions of explosions happening in the engine over the course of a drive. So, your car blows up gasoline inside of the engine, and that's how it powers itself. So that produces a lot of heat. It also produces a lot of light. Now, we don't see this when we're in cars, but if we lit gasoline outside of the car, we would see a flame. That's heat and light. And then the final thing, the thing that we generally actually want to get from the gasoline, is mechanical energy. And so those explosions move the pistons in the engine that powers the car and sends us along our way. And so when we use exergonic chemical reactions, we get a lot of energy out as sound, heat, light, and mechanical energy. And so we burn fossil fuels mostly to get that heat and that mechanical energy. The mechanical energy mostly in transportation, and that heat we can use to generate electricity. So that energy that we get out of these reactions is what makes the exergonic reactions from fossil fuels really useful to humanity.